Hey all, thanks for attending. Yeah, let's just start it. So quick intro, my name's Anirudh. I lead enterprise product at Together. And so quick overview of what we're going to be covering in this talk, just a quick intro into who Together is and what we do. What some of the success we've worked with RAG and enterprises and some of the kind of standard architecture that we've built out using RAG with a combination of Together and MongoDB Atlas. How we've key lessons we've learned in refining RAG with more advanced techniques and how open source large language models factor into that. Some of the benefits this incurs for financial institutions, key learnings and takeaways we've garnered as a result of doing this, and then how you can actually get started building things like this out. So to be brief, Together is basically an enterprise acceleration platform. And what that means is we built LLM infrastructure and a platform to allow developers and enterprises to build and orchestrate all of their generative AI workloads with optimal performance and minimal cost. So what does that actually mean, right? So this is just a kind of a high overview of our overall platform. So what we built and kind of highlighted in the blue are these three main engines, right? An inference engine, a fine-tuning engine, and a training engine built from the ground up, the scheduling and orchestration around all of this. And so end-to-end workflows when it comes from fine-tuning to inference or even training large language models are all supported on the platform. And the thing to note here and what makes it different is we're very research focused. Our whole vision is bringing research to production. And so our inference engine, for example, has been built from the ground up, from kernels to system level to ML level improvements. So it tends to outperform open source alternatives like VLLM, TRT by 30 to 40%. And the implication of that is that you reduce your overall TCO as a result of running faster. And the way we built the platform is so that it's environment and hardware agnostic. So we sit on top of commodity hardwares, NVIDIA GPUs, and we deploy either on customer GPUs and on-prem clusters and customer VPCs, so we support all the major hyperscalers, or we run our own cloud, so we provide inference, fine-tuning, and training APIs. So some of the enterprise, this is just a selection of some of the enterprise customers we've worked with to basically help them orchestrate and run their generative AI workloads and improve their inference performance while maintaining data privacy and security. And so what I'm going to be talking about in this talk is some of the learnings we've learned as we've helped enterprises scale up in their generative AI journey. So initially, we're just going to talk about RAG and show a reference architecture we built using Together.ai and MongoDB Atlas. So as a quick kind of just summary for those not familiar with RAG, you're basically combining information retrieval with large language models. So it allows you to augment large language models with your sources of information within your internal knowledge base. And so to give a kind of financial example, one common one we've seen is answering complex queries about investment products. So the RAG process here is given a user query about your internal investment products or internal theses. The RAG pipeline should retrieve your latest fund data, your risk assessment, your relevant regulations from your internal knowledge base, and then generate, using the large language model, provide that in its context and generate a comprehensive, accurate response. And so the idea here is you can ground it within your internal knowledge base and get precise, up-to-date, and compliant communication and make sure that everything is very specific to your institutional knowledge. So the benefits for financial institutions here are, one is enhanced accuracy, right? So your responses are based on your latest institutional data, and you're not relying solely on the large language model's kind of base source of information. Two, and I think this is really one we've seen resonate with enterprise customers on the financial side, is the improved compliance and transparency, right? So you can actually cite the specific documents and knowledge through which the large language model is generating its response. So this gives you kind of an audit trail and a very easy way to remove the black box of kind of the large language model. Customizable knowledge, right? You can fit this to institution-specific policies and knowledge, reduced hallucinations because you're actually grounding it in your internal knowledge and your internal kind of data. And then real-time adaptability, which is the other major benefit, right? Instead of having to retrain the model and constantly pay this cost to retrain the large language model, you can actually update it dynamically as your internal knowledge base or internal documentation base improves. So what does RAG with Together and Mongo look like? So the first step is actually the vector database creation, right? So these are internal documents that need to be actually stored and codified. And so what we do is Together.ai offers, a variety of different embedding models, and we have an embedding endpoint. So what you do is you'd basically connect your internal knowledge base to these embedding endpoints. They'd be connected, and you generate embeddings, and then we built a very seamless, kind of easy-to-use integration with MongoDB Atlas. So those embeddings are then stored in the vector database, which is MongoDB Atlas. right? And so once this happens, a user submits a financial query, for example. So what were the Q4 earnings of some company? This is, again, using that same exact embedding endpoint, converted into the vector. And then what happens is Atlas comes with kind of a built-in similarity search. So you're going to do a similarity search using basically finding all the documents that are most relevant and similar to your query. And Atlas will then, compare the embedding from your query to all the embeddings you stored from your internal knowledge base and find the most relevant ones, right? So you have your entire knowledge base and it does a really quick search to narrow this down. So this is where most RAG systems are, this is what people kind of consider the basic RAG system. But what we found is this isn't actually sufficient, right? What you really want to do is go a step further. And so this is where re-ranking comes in. So what re-ranking actually does is it allows you to take the documents generated from the initial vector search and really filter them down into a high priority list based on semantic similarity to your query. So what does that mean? What it means is you really want the most relevant documents to be injected into the context. And so you almost want to do this refiltering and re-ranking. And the reason why you can't do this from the get-go is your internal knowledge base is huge, right? So you need a very quick and fast method to initially filter it down. That's where the initial vector search via Atlas comes in. But then you want to use a more computationally intensive and powerful model to actually re-rank those. And so that's exactly what we have. And so Together offers several re-ranking models to allow you to do that. And we found that this has incredibly powerful kind of end results for your end-to-end RAG pipeline. Once you've gotten these re-ranked models, the next step then is to actually format them and put them into the large language model context or the input that's going into the model itself. And then finally, what you do is you feed that input into the model and it generates an answer. And again, this is kind of the final endpoint is the Together AI large language model. This is the actual model you're using. And here we have a variety of hundreds of open source models. So you can choose between models trained on specific data or models at varying sizes depending on your compute and latency and throughput SLAs. And so this is kind of the overall thing. And so really overall architecture and what you have are these three endpoints, right? The embedding endpoint, the re-ranking endpoint, and the large language model endpoint, as well as MongoDB Atlas. And so this is a kind of your prototypical RAG pipeline. And usually people start out with this as phase one, right? They use standard out-of-the-box models, and this is what works. But what we found is there's actually significant ways to improve upon this once you've built this as your first prototype. And so this is how you actually go about improving it. And so some of the financial institutions and customers we've worked with have derived a lot of the learnings I'm about to show you. So that first thing is on the embedding point, right? So actually improving your embedding strategy and improving your embedding endpoint. And so what we found is that using open source embedding models, great way out of the box, but really what you want to do is you actually want to use multiple types of embeddings. And so specifically for financial institutions, things like financial specific terms, differentiating between different types of filings and earnings reports. All of these make a tremendous impact. And so things like financial specific embeddings or multilingual embeddings, where if you have multiple languages in your corpus or you work on international markets, things like that, you need a embedding model that can actually capture the nuances in different languages as well. And then temporal embeddings. So these are taking into account the recency of the data, right? Financial data or any kind of data really can change quite quickly, specifically in the financial realm. So you need to account for the recency. And so some techniques that we've seen are either people using fine-tuned embedding, open source fine-tuned embedding models that have been trained for financial data, or even fine-tuning their own embedding model on their own financial corpus. The other things we've seen is ensemble approaches. So actually taking these three types of embedding, doing a kind of weighted average over these, and combining them so that before you put them into your vector DB, you've incorporated all the different types of information from financial to multilingual to temporal. Or something like contrastive learning, which is at a high level a way to learn the nuances between very subtle terms in your corpus. And so the impact here is, when you do your vector search using MongoDB Atlas, the better your embeddings are, the more information they capture, the more relevant and higher accuracy documents you're going to get. But similarly, on the re-ranking side, as I mentioned, re-ranking is a function of basically balancing, how much compute and power you're willing to back behind it by how much performance gain you're going to get. So, you want to be testing multiple re-ranking models and seeing, what's my marginal improvement on accuracy and how does that lead to end improvement in my RAG pipeline. And so we offer a variety of these, but we've seen people do things like either use out of the box or train custom cross-encoder models, which are models like BERT that have been fine-tuned on financial data. And so these are actually transformer models that are being used to re-rank, or learning to rank models or relevant classifiers. And so these are there's a whole spectrum of kind of re-ranking models. And as you go from low kind of compute complexity to high compute complexity, you get more and more performance, and you basically need to assess, what's the improvement on the end pipeline. But this has an incredible impact, as I kind of mentioned before, as you play around and experiment, depending on your use case, on improving the ability of your large language model and your RAG system to work correctly. And then finally, and arguably the most powerful, is actually fine-tuning your end large language model for the financial use case itself. And the reason you do this is richer customization, so actually controlling your input and output formats to make sure they adhere to your guidelines and the formats of, if you're generating a market research brief, for example. But probably the largest reason is using a smaller model, right? So initially you start with a large model that's quite capable, but as you scale this up to production and you really see the rubber hit the road and the unit economics of large language models come into play, fine-tuning a model allows you to bridge the quality gap between a smaller model and a larger model. And so that really leads to lower compute costs, faster speed, so better user experience, and overall lower cost. And then things like domain adaptation to your financial use case and basically more control over the model are the results of fine-tuning it for financial use cases. So to walk through a case study, specifically on the fine-tuning side, because I want to double-click on this. So we worked with a large financial institution building out a RAG system to automate market research briefs. And the approach they were doing was to fine-tune a smaller open-source large language model on their internal financial knowledge. And so the first thing they did was take Llama 3 8B, so an 8 billion parameter model, and fine-tune on their internal data. Then they compared it to a Llama 3 70B generic model, as well as the closed-sourced OpenAI GPT-4o model. And what you're able to actually find is that when you fine-tune, and even with a couple thousand examples, Llama 3 8B fine-tune was actually able to beat the generic model and was comparable to the closed-source model. And so what are the implications of this, right? The implication is, one, namely on the speed side, you get 60% faster response time. And so for a RAG system, especially real-time systems, this can have an incredible impact on end-user kind of behavior and experience. And then more significantly is on the cost, right? So a 55% reduction in compute costs, right? And so fine-tuning these models in this RAG system tends to be a great way to bridge that quality gap, as I mentioned, and really scale this up to production in a way that makes sense from an ROI perspective. And so some of the learnings overall is that you really need to balance between cost, accuracy, and latency trade-offs, and really assess this performance cost benefit. And this is, I think, something that enterprises are still learning to do with large language models. The unit economics, the cost of serving these are fundamentally different, especially as you build RAG pipelines with multiple models involved. And so really needing to assess, almost like in an ablation style way, of how much, as I improve my embedding model, as I improve my re-ranking model, as I improve my end model itself, how much performance benefit do I get? What's the end system performance? And then what's the cost to do so? And what we found is that marginal LLM accuracy improvements by using a much, much larger model, bigger is better is not always true, does not always directly translate to end business metric improvements or make sense from a performance cost trade-off perspective either. And so that's why, as I kind of mentioned more of these advanced techniques, we at Together kind of believe that the future of AI is open source, because you need the kind of fine-grained customizability of these models to improve your RAG pipeline, to move beyond that phase one that I illustrated of just using vanilla open source models. You need, as specifically for kind of enterprises and financial institutions, you need data privacy and control. You need full control over the deployment. You need to know what the model is trained on. And as we've seen recently with a lot of the meta models, you can leverage, open source has been exponentially improving in terms of its capabilities, and now is meeting frontier and closed source models and actually achieving performance parity. And so you can really benefit from that. And so the benefit here is you reduce the dependency on a lot of the closed source and proprietary solutions. And I think one understated benefit is there's a whole wide range of models. So as you assess this cost performance trade-off, you can look at things that, you can get access to fine-tuned specific models on financial data, but you can also get access to a wide range of parameters and wide range of models depending on your compute and application requirements. And so really what we've seen as we've worked with enterprises, this is the stages that enterprises go through, right? It's initial exploratory bets, with closed source providers like OpenAI. As these bets start to translate, early bets start to translate to production, we've seen folks experiment with vanilla open source models, not fine-tuning or anything, but just trying to do a swap with their closed source model due to, as I mentioned previously, cost concerns as, production scales up. The closed source models tend to be quite expensive, or they have less granular control, speed and privacy concerns. And then finally, that phase 3, which is more of what I was talking about in the improving your RAG pipeline in a more advanced step, as production really gets to go into full production scale, you see folks start to fine-tune open source models, implement more complex pipelines, and really get granular and start optimizing this cost-performance trade-off. And so the key takeaways that I would leave you with is that I think what we've learned is that open source large language models, from both the cost and performance standpoint, offer and a privacy standpoint, offer a powerful foundation for financial services, and that these advanced techniques can significantly enhance end system performance while also improving, cost and speed, and that fine-tune smaller models and can really bridge that quality gap and offer performance and cost-effective alternatives to larger, more generic models. And the way to think about this and the way I'd advise you all to approach this are these are phased rollouts with increasing degrees of complexity. So as you go from phase 1 to that phase 3, start with a simple prototype, and that's akin to that reference architecture I mentioned, and then keep assessing that cost performance and the end business metric and kind of tune each of those knobs from re-ranking to embedding to your end large language model. And then lastly, us plus MongoDB have built a pretty comprehensive privacy-focused RAG solution to help you get these prototypes set up quickly in a very seamless manner. And so, as I mentioned, I would start with evaluating your needs, identify key use cases for RAG, and then place early bets with the more standard RAG system, then iterate in that kind of phased rollout that I mentioned. If you'd like to do so, I would encourage you to explore Together plus Mongo. So you can just sign up for a developer account at Together.ai. We have our own cloud, as I mentioned. It's a very easy starting point. We built an integration with Mongo. And you can set up a small-scale RAG prototype. That architecture I mentioned, we have a full blog on how to do that. And you can set that up and test it out as phase 1. And then happy to help with, as we mentioned, our enterprise platform supports this as you go to phase 2 and phase 3. So appreciate the time and happy to answer any questions you all have now. Thank you.